Hello everyone. In today's video, we are going to talk about inverse function. So what is inverse function? Well, by definition, the inverse function, if f(a) equals to b, then a function g of x is an inverse of the f function if g of b equals to a. So typically, the inverse function of fx, we usually notate it f inverse of x. There's a little bit negative one on the exponential place, which we read it f inverse of x. So equivalently, GB equals to A, if we write it into inverse function sign, it should be F inverse B equals to A. Okay, as you can see, do you find some patterns in here? The inverse function and the original function. Well, you may notice that, hey, the input of the original function becomes the output of the inverse function. Similarly, b originally was the output, right? And now it becomes the input of the inverse function. So things like that we see quite often, more than you think you see every day in your life, such as if I given you a Fahrenheit and now you travel overseas, most of the foreign country, they use Celsius. So if I tell you that, hey, today is 75 degrees Fahrenheit, and I want you to convert these to Celsius, what do? Well, I given you a function, which is the Celsius function. Okay, you know that there's a relationship between the Celsius and Fahrenheit, but now you know that, hey, it's given the input is 75 Fahrenheit, right? You want to convert these to Celsius. So this has become what? 5/9 minus 32. And then this is 5/9. This is approximately, I'm going to skip the calculation here, 24 Celsius. Okay, but what does the inverse look like? The inverse function is more like you are given the Celsius and now you want to compute what is the Fahrenheit. So for the formula, it's going to be Fahrenheit equals to 9/5 of the Celsius times Celsius plus 32. So that means if your input is a Celsius, such as maybe 20 degree, then you will have the output as Fahrenheit, which is 9/5 times 20 at 32, which is this is 436 at 32, which is 68. So this is going to be 68 Fahrenheit. So in that case, these two functions is the inverse function of each other, which is your input become the other's output. All right. So in a particular function, what do we know about it? So if I given you a function f of 2 equals to 4, what do we know about the inverse? Well, the inverse function should be reverses which quantity is the input and which quantity is the output. Well, if you think about it, this is your input, right, originally? So now in the inverse function, this has become your output. This has become the input of the inverse function. So inverse function notation is f of the inverse of f function. Input is 4, output is 2. Similarly, if I given you an inverse function, h inverse 6 equals to 2, so what do we know about the original function? So that means we know that, hey, h of 2 equals to 6. Remember, the inverse and the outverse are going to be reverse. So in that case, that means whatever input is going to become your output, every output is going to be your input. So that means the domain of the original function is the range of the inverse function, right? Because domain is all the possible value of the input and the range is all the possible value of the output. So that means the range of the original function is the domain of the inverse function. So on the mapping graph, it should look like something like this. The domain, if that's the domain of the original function, and here's the range of the original function. If is a original function, it should be from A, you put in A, you will get B if you operate the original function. But for inverse function is, if you operating from B, you will give you the A. So that's the opposite. Okay, so for example, if I tell you that, hey, the function fx equals to 2x, 2 to the x power, and has the domain of negative infinity to infinity, and the range is 0 to infinity. What do we expect the domain, the range of the inverse function? Well, in that case, we will expect the inverse function has the domain, which is here, right? Negative to 0 to positive infinity. And the range is what? The domain of the original function, which is negative infinity to infinity. Okay, so now think about it. A function is given in this table. Let me show you the example. So here's our example. A function f of t is given a table below showing the distance in miles that the car has traveled in minutes. Find and interpret f inverse 70. Okay, so now let's look at the original function f of t. So f of t, what does that mean? So t is your input, which is minutes. How long? Has been driven. And then what's the output? output f of t is the output, is how far away has been traveled, right? Different. Okay, so what does the inverse means? Well, the inverse is the opposite. Your input is become the mileage, the distance that you travel. What's the output? Output is the time, right? It becomes the time because they flip it. So now let's take a look. When the output equals to 70, the input equals to 90, right? So that means, how do you interpret this? It means to drive 70 miles, it took 90 minutes. Easy, right? Well, alternatively, if we record the inverse, that is FA equals to B, then we have the inverse function. By the definition, if we are given that the inverse function of 70 equals to some certain number a, then you're looking for the value of a, so that f of a equals to 70. So that's why we are locating, hey, when the output is 70, a is equal to 90. That is going to be the output of the inverse function. That's similar to graph problem. So at beginning of the class, we talked about the Celsius and Fahrenheit. So now I would like to talk about how do we find the inverse function if I'm giving you a function. So for example, if I'm given a function y equals to 2s plus b, let's use fx, plus 4, I want you to find the inverse function of the fx. How do you do that? Well, the first step is you write fx equals to y. So that means I write it y equals to 2x plus 4. Second step, you swap x and y, okay? You swap the position because your input is going to become your output is become your input. So when I swap it, I have x equals to 2y plus 4. Step 3, you want to solve for y, because you want to move y on the one side and x on the other side. So in that case, I have x minus 4 divided by 2, that is equal to y. The last step, after you've done all of this, you want to write y equals to the inverse function, because now it's the inverse function. You're already swapping x and y, so that means you're already swapping input and output. So now the inverse function equals to that. Okay, well, let's try the Celsius and the Fahrenheit function and try to swap them. Okay, so the function we have, the Celsius equals to 5/9, Fahrenheit subtract 13/2. I want you to find the inverse function of the Celsius. Well, the first step is what? Now we can skip the step 1 to rewrite fx to y. We can just do the swap, which is f equals to 5/9 Celsius minus 13/2. Okay, step 2 is we are trying to solve for what? Celsius. So I have F times 9/5 equals to C minus 13/2 and add 13/2 on the both sides. And now we have our inverse function, which is the inverse Celsius equals to 9/5 F plus 13/2. Okay, does that look weird to you? Like the inverse of C, that should be F, right? And then F, and then F. How can you put a Fahrenheit and your output still a Fahrenheit? That means we missed something. What do you think we missed? Well, that means in here, we still need to rewrite these F to become an inverse. Because earlier, the reason we did that because we swap X and Y. Or what you can do is you can, if you do the inverse of the Fahrenheit, later it will make more sense to you. Because if you do the inverse of Fahrenheit, later when you have this C Celsius inverse, that gives you the input, the output of Fahrenheit, right? And then the inverse of the Fahrenheit gives you a Celsius. Then after you've done the swapping, you know that, hey, when the input is a Celsius, you will get the output of a Fahrenheit. All right, so now I want to talk about something. Does all the functions have inverse function? Nope. So the property of an inverse function, this is very important. In order for a function to have an inverse, it must be a one-to-one function. What is one-to-one? So that means each input is going to correspond to one unique output. So earlier when we talked about in chapter 1.1, we talked about what is a function, what is a one-to-one function, and we introduced the horizontal line test and the vertical line test. Remember, to be a one-to-one function, you have to pass the vertical line test. Oh, sorry. To become a function, you have to pass a horizontal line test. A vertical line test is to determine whether you're a function or not. Okay. So another property of an inverse function is the graph. The graph of an inverse function is very interesting. So they're going to be a symmetric about y equals to x. So what does the y equal to x? Well, y equal to x is what? The identity function. If you have a inverse function like that, this is your original function, fx. What does your inverse function look like? So your inverse function should look like this way, because it should be inverse about the identity function. Or if you have a inverse function, if you have an original function look like this way, that's the original function, and your inverse function should be symmetric about the y equals to x, which is the dashed line in here. So your graph is going to look like this. All right, so that's it for the introduction of inverse function. Let me know if you have any questions.